All right, great. So I looked at the predictive power of the determinants of interstate migration in the United States. And the reason that I wanted to investigate this is because basically it's really pertinent to my life at the moment. I'm currently moving from New York to Arizona. So anecdotally, what I'm doing really supports what we're seeing in the data, that people are moving from places like New York and California and moving to places such as Arizona. Maricopa County, for example, is one of the fastest growing counties in the US, with an influx of about 200 people per day. But it's not just Arizona. There's other metropolitan areas such as Dallas and Miami that are seeing a huge boom in population. So while I have my own reasons for choosing to migrate, this just made me ask the question of, what do these states have to offer? Like, what do these states have in common that are encouraging people to move to them? And I chose to do my analysis on the state level and between the years of 2010 and 2017, because I also wanted to explore what all of this impact has on the American electorate, which is population data at the state level. So at the end, I just went on a little tangent of how all of this migration is impacting or could impact the congressional reapportionment. So I used net migration data from the US Census, the American Community Survey's one-year estimate program, where people report if they are currently residing in a state different than the state that they reported a year ago. So I used each state's total out-migration and subtracted that from the total in-migration to get the net migration for the year. And then I used the sum of each year to get the net migration totals. You can see that Florida, Texas, and Arizona are among the top three. Florida saw a net migration increase of about 870,000 residents. And then states like New York saw a loss of about 1.17 million people between those years. And there's a bit of a spatial autocorrelation here. You can see that people are leaving what I like to call the Rust Belt or the Snow Belt, and moving to places along the coasts and basically where you would expect there to be sunnier weather. So the migration determinants that I looked at were first the crime rate as a bit of a proxy for quality of life. And then I looked at home price, income, and unemployment rate as three economic proxies. And then I looked at January weather as a climate factor. The unemployment rate across the states throughout the years, you're seeing the highest rates along, videos in my way, highest rates along the southeast and the west coasts, and then they decrease as you go further inland. And then there's a little cluster of a really low unemployment rate in the middle, where North Dakota, Nebraska, and South Dakota, so three really rural states. And the highest unemployment rates are in Nevada and California. And then income, we're seeing the lowest income pretty much spanning throughout the South, with the highest income cluster up along the Northeast, kind of surrounding New York City, but not including New York. So Washington, D.C., Connecticut, Massachusetts, and New Jersey. Housing price is showing a really positive spatial autocorrelation, with clustering of low house prices up along and along the lower Midwest region. And then there's an increase as you move towards the Northwest and Northeast corners of the US. And then crime rate, there's not a real obvious spatial gradient, but there's some regional clusters that are indicative of a positive spatial autocorrelation, showing that the highest crime is kind of scattered throughout the US, but the lowest crime states are clustered, with the lowest ones being up in Maine, Vermont, and New Hampshire. And then January temperature pretty much shows exactly what you would expect it to show, that there's a gradual temperature decrease as the increase, as you increase in latitude. So to take into account the spatial nature of the experiment, the next steps were to use GEODA to assign spatial weights and to confirm that there is a positive spatial autocorrelation among the data, and then test for multicollinearity among the variables, and then to determine the best fit regressive model, and then to analyze which of the independent variables have the greatest impact on migration using the best fit model. And then just as a supplemental aside, just to explore the relationship between net migration and the congressional reapportionment. So I used a Queen's contiguity to account for each state's neighbor adjacent and diagonal to it, and Alaska and Hawaii obviously had no neighbors, but most states had between 3 and 6 neighbors. So the weighted variables were used alongside the unweighted variables and revealed the Moran's I values that all showed evidence of positive spatial autocorrelation, especially the January weather, the unemployment rate, and the income. So that basically just said that you couldn't use a standard regression. You have to account for all the spatial factors happening. And then to address the multicollinearity dilemma that was noticed just from some explorative scatter plots, it looked like there was a redundancy between home price and income, and that crime and unemployment rate were looking to be correlated as well. So the R-squared values between these variables revealed that, confirmed that there was multicollinearity. And since crime rate didn't look to have much of an impact on net migration, I chose to remove crime rate as one of the variables. And I chose to remove home price from the variables as well. And so, sorry, 1 minute. Okay. So the ordinary least squared regression with the 5 variables just provided a benchmark for improving the model. And it first provided, the confirmation that the multicollinearity number was really high with all 5 variables of 30. So removing the 2 variables of crime and home price, the multicollinearity condition number decreased. It's still a bit high, but it decreased, so that's good. And then the R-squared in the spatial error model decreased compared to the ordinary least squared, the standard regression model, and compared to the spatial lag model. The standard error of regression decreased, the log likelihood increased, and the AIC value decreased in the spatial error. And then looking at the p-values, I found that all variables became more significant under the spatial error model, but income was just above the threshold of the 0.05, and unemployment was well above it at 0.73, so neither income nor unemployment rate were statistically significant factors influencing net migration values, whereas weather did reveal to be a statistically significant variable. So basically, the spatial error regression model revealed a higher R-squared value, a lower AIC value, a lower standard error, and a higher log likelihood number. So that indicated that it was a stronger model in predicting the dependent variables than the standard regression model or the spatial lag models. And then while all the variables became more significant under the spatial error model, only the January weather had a statistically significant impact on the net migration. So overall, though, with an R-squared value of 19.8, that means that about 80% of the variation in the net migration is not being explained by the variables that I chose for this study. So some further work that I would like to investigate is why the unemployment rate has little impact on migration. And one possible explanation could be that the people who migrate are also often the people with a college education. And perhaps college educated people are able to move to places that have a higher unemployment rate because they're able to obtain jobs that maybe people without a college education are able to obtain. So maybe something around this could be skewing the data, or there could be factors related to seasonal or part-time employment that are getting in the way of the data. And then also I'd like to look at how migration determinants differ across demographics, mainly stages in life. So younger generations, what they're considering. Maybe younger generations consider economic proxies more, while retired migrators might consider things, other quality of life proxies like the crime rate or the weather or something like that. And then I'd also like to look at splitting up in migration and out migration and seeing how the migration determinants relate solely to those on their own. So what is bringing people in and what's pushing people away from states, basically, as opposed to, you know, I think it's just a bit more complex when you do in and out migration because you're looking at reasons people are going to that state and reasons that people are staying in that state. So those reasons could differ greatly. And then just additionally, I just think this is an interesting little aside because a lot of the changes, most of the changes in state populations have to do with the migration numbers. So every 10 years, the state population data from the 10-year census is used to reapportion the congressional seats based on the changes in the state population. So each state automatically receives one seat, and then the 385 seats are then apportioned out based on the population. So currently the average constituents per congressional district is about 750,000. But as of 2017, the states that are in the red and the orange are considered pretty underrepresented because their population increased by so much. And then the states in the blue are severely overrepresented in the US Congress because they have such a small number of constituents. So basically every 10 years, the House of Representatives likes to even the playing field here. So instead of just dividing the number of seats by the population, they use a method of equal proportions where they use the current state population and divide it by the geometric mean of its current and next seats in order to return this equal proportions outcome table. And this is repeated the 385 times to basically divvy out these seats evenly. So the first return of this equation is here, and it's not enough definitively to say which states are going to receive and lose seats, but over the overlap that you can see in the table of net migration, the equal proportions outcome, and the number of constituents per congressional district, you can see that Texas comes up in all of them. North Carolina, Colorado, and Oregon are most likely to be the winners in this scenario. So if the decisions were being made based on the 2017 data, I would predict that Texas, North Carolina, Colorado, and Oregon would see the greatest benefit in terms of the congressional reapportionment and each be granted at least one additional seat, whereas states like Montana and Delaware, as you can see here, are representing over 1 million constituents with one congressional seat, and Delaware will probably reach 1 million by 2020. So they're just very underrepresented. So it's likely that they would also receive an additional congressional seat, but it's not as much of a result of the interstate migration to the degree that Texas, North Carolina, and Colorado, and Oregon are seeing. And then I would like to explore this a little bit more and repeat the equal proportions equation, you know, the 385 times, but with the more current, up-to-date 2019 state population data to better predict which states will gain and lose. And my guess, my hypothesis would be that Arizona would probably be among the gainers of another congressional seat after 2020, and then along with Florida, and then perhaps Idaho, Nevada, and Utah. But we'll see. This is just a little interesting aside that I just wanted to add, because migration has such an impact on, it has the ability to have such an impact on the American electorate. But yeah, that's it. Those are my references, and I'd be happy to answer any questions.